Hi everyone, this video is on transformations. So the graph of any function can be obtained by applying a combination of the following transformations, either reflections, translations or dilations. So to make a reflection happen, you can reflect about the y-axis or the x-axis. To reflect about the y-axis, you make the x in the function negative, and to reflect about the x-axis, you make the whole function negative. Translation, so translation is where it moves, and it can move vertically or horizontally. To move a graph vertically, you add a value to the end of the function. If it's horizontally, you add or subtract a value to the x within the function. Now note here, you see the general form there is f of x minus h. So if the h is positive, it means it will be x minus still, and so it moves to the right. If h is less than 0, which means it will be a plus in this equation, then it moves to the left. Now in an IB exam, if you're ever asked to describe a translation, you need to either say it translates or it shifts vertically or horizontally. Do not use the word move, you will get 0 marks. Dilation, you can have vertical or horizontal. So a vertical dilation is where the whole function is multiplied by a value a. Now if the absolute value of a is greater than 1, so that basically means it's greater than 1 or less than -1, then it will stretch. If the a value is between 0 and 1, so it's basically a fraction, then the graph compresses. Now, quick note here and hint, for a vertical, the x value stay the same and the y value would change. Then with a horizontal translation, the x in the function is multiplied by a value. The scale factor is 1 over the absolute value of that number b. So if the b is between 0 and 1, so a fraction of between 0 and -1, it will stretch horizontally. If the b value is greater than 1 or less than -1, it will compress. So I like to think of it this way. If that b is, say, a 2, then everything's happening twice as fast. So the graph will be squished because it's happening quicker. And a quick note here, the y values stay the same, but the x will change. And you'll see how that works when we do some examples. So first of all, this example here, we've got the graph with the blue background is our general graph, and we're going to translate that. So the first one, we've got y equals 2 f of x. Now a 2 f of x means it's a dilation vertically. So what will happen here is, and you see that little note I wrote above with that vertical translation, x values stay the same, it's the y that changes. So if we have that 2 out the front, which means everything is stretching by 2. So we look for some important points in the graph, so I'm going to look at these ones that I've circled. Now if we look at the first one, which is at -2, 3, the x values stay the same, so it's still going to be at -2, but it's stretching by 2, which means it won't be at 3 anymore, it will be at 6. I'm going to plot that point. The y-intercept is at 0, 2. Stretching by 2 means it will now be at 0, 4. 4, 2 is the next point, which will now be at 4, 4, so it stretches by 2. And the last value is at 6, 0. If we multiply that by 2, it's still going to be at 6, 0. Once we've done that, we can join our dots. And that is how a dilation, a vertical dilation works, with a value greater than 1 in front of the function. B, y equals f of -x. So that means it's a reflection because we're making something negative, and -x reflects amongst the y-axis. So everything's going to reflect across the y. So we're going to just look at those 4 points again. The first one at -2, 3 will then be at 2, 3. So it reflects to the other side. 0, 2 will stay the same because you can't, if it's on the y-axis, it's not going to reflect anywhere. 4, 2 will then go to -4, 2. And 6, 0 will go to -6, 0. And then join our dots up. As you can see, it is just reflecting across the y-axis. C, we've got the function of f of 2x. So the 2x means it is a horizontal dilation. Now because it is a 2x, remember what I said before, that means everything's happening twice as fast. And a little hint here, remember the y values stay the same, it's the x values that change. So let's look at our 4 points again. So negative 2, 3. So it's still going to be at 3. Our y value stays the same, but it's happening twice as fast, and now it will happen at negative 1. 0, 2. Happening twice as fast, it's just going to still stay at 0 because half of 0 is still just 0. Now the next point at 4, 2. So it's still going to be at 2, but it's going to happen twice as fast, so the 4 is going to move into 2, so it's going to be at 2, 2. And 6, 0, the y value stays as 0, but it's happening twice as fast, so that will now be at 3. And then we join our dots. And the last one, we have the function x minus 1, then everything minus 3. So the minus 1 and the minus 3 are translations. So we're going to shift the graph up and down or left to right. Now the minus 1 means we've actually put a positive value in there. Remember that? So a minus 1 in there means we're moving it to the right. So everything's going to move to the right, and the minus 3 means everything moves down by 3. So if we look at our 4 points again, so the one at negative 2, 3 is going to move 1 to the right, so that's going to go to negative 1, and it's going to move down by 3, so that value, so that point will end up on the x-axis. The intercept, 0, 2, it's going to move across by 1 to the right, so it's going to be at 1, then it's going to move down by 3, 1, 2, 3, so then it will end up being at negative 1. The point 4, 2, move across by 1 to the right, so it'll be at 5, and then move down by 3, will be at negative 1. So 5, negative 1, and then the x-intercept at 6, 0 will move across by 1, so it'll go to 7, and move down by 3, so it'll be at negative 3. And then we join the dots. And that's the basics of translation. So we're going to do some more practice now, but we'll do it with a quadratic graph. So example 2, sketch the quadratic y equals x squared and the graph gx on the same axes. Write down the coordinates of the vertex and the equation of the axis of symmetry. Alright, so I've already put in the graphs of x squared, so then we just have to draw the new graph on top of this. So we've got half of x squared, so that half in the front means it's a vertical dilation. Now because it's a half, it means it's actually going to compress vertically. Now in this one, remember the x values stay the same and the y change, then the y values will halve. So there's a few points here that we can look at nicely. So x values stay the same, so I'm just going to put a couple of these in here. So his first point on the left hand side is at negative 2, 4, because negative 2 squared is 4. Now, if we are going to half that, remember the x values stay the same, it will now be at negative 2, 2. Negative 1, 1. Well, the x value stays the same, so it'll still be negative 1, but now we're going to half the 1, so it'll be a half. It will still stay at 0, 0, because we half 0, we get 0. 1, 1, it will then be at 1.5. The 2, 4 point will now be at 2, 2, because we're halving the y value. And then from there, we can just sketch the graph through those points. Now remember, in a sketch, it means the graph doesn't have to be perfect, it just has to resemble what it should look like. Now we also want to write down the equation of the axis of symmetry and the coordinates of the vertex. So our vertex is our maximum or minimum, so I've just circled it in orange. So the vertex for this one is at 0, 0, and our axis of symmetry will be at x equals 0, because remember it's the x coordinate of the vertex, but we have to write it x equals. Here, b, we've got x plus 3 all squared minus 2. So here we've got our x value and we've added 3 to it, so that's going to move it. Now it's a plus 3, so it's going to move to the left by 3. Then we have a minus 2 at the end, which means it's going to move the graph down by 2. So if you look at our origin first, it's going to move to the left by 3, and it's going to move down by 2. So our minimum is going to be at this point here that I've just put a dot at. It's going to be at negative 3, negative 2. Now our next point is the one these two here, the 1, 1 and the negative 1, 1. So if we look at the negative 1, 1 first, it's going to move to the left by 3, 1, 2, 3, and down by 2, so it will be end up here. The 1, 1 point, move to the left by 3, move down by 2, will end up there. Then we have our 2, 4 points. Once again, move across by 3, down by 2, move across by 3 and down by 2 on the other side, and then we can start joining up the dots. For this one, our vertex, our minimum, is now at this point here, which is at negative 3, negative 2, and the axis of symmetry will be at x equals negative 3. Next one, we've got 2x squared plus 3, so which means it's going to be a vertical stretch, because we've multiplied the x squared by 2, and then we're going to add 3 to it. So once again, we're going to look at, let's start with our origin point, vertical stretch it by 2. So when we vertical stretch, it means the x value stays the same and the y changes, but 0 times by 2 is still 2, so it's going to stay there, but we're going to move it up by 3 because of that plus 3. So the origin will move to 0, 3. The point 1, 1, this one here. Multiplying by 2 for the 2x squared, so that will now be at 2. Then we're going to add 3, 1, 2, 3, so that will end up, that point will end up being at 5. The 2, 4 point, multiply it by 2, which means it'll end up being at 8, and up by 3, which is past our graph. The negative 1, 1 point will multiply by 2, so it'll be negative 2, and then it will go up by 3. So it'll be there, and then we can sketch the graph. D minus 3x squared. So first of all, at minus 3x squared, the whole function is minus. So it's going to flip across the x-axis. Then it's 3 times, so all our y values will multiply by 3. So let's start at the origin. So the origin is 0, 0, which is going to end up staying the same because we reflect it, it's still going to be at 0. If you multiply 0 by 3, it's still going to get 0. Now let's have a look at our 1, 1 point. So if we reflect it, it's going to go to negative 1. Then if we multiply it by 3, it's going to go to negative 3. So it'll be there. Our negative 1 point, this one here. If we reflect it, it's going to end up here. Multiply it by 3, it's going to end up at negative 3. There. Now our 2, 4 point here, if we reflect it, it's going to go to negative 4 here. Then if we multiply by 3, it's going to end up at negative 12, so it'll be off our graph, and that's the same with the other side. So really we have enough there to then sketch the graph. Oh, and I forgot to do the axis of symmetry and vertex for part C as well. So the vertex of part C is at this one here, so it'll be at 0, 3. Axis of symmetry will be when x equals 0. And then for part D, our vertex is still going to be this point here. It can be a maximum. So our vertex will be at 0, 0, and our axis of symmetry will be at x equals 0, the x coordinate. Okay, example 3, we've been given the graphs, now we want to write the equation. So the purple line is our y equals x squared. And we want to see what do we have to do to that to get the other line, to get the next graph. Now if we look at the green graph, we can see it's been reflected across the x-axis, which means the whole function will be negative. So we're going to have y equals, it's going to be, the whole thing's going to be negative with the x. Now the x, we can see here, this, if we look at the origin, it has moved across from there to here. It's gone from 0 to negative 4, which means it will be a plus 4 in the brackets there. It hasn't moved vertically up or down. Now we need to see if a stretch has happened. Now if we look here, it's still moving the same pace, so the 1, 1 point has moved across by 4 and then been reflected. So it hasn't actually stretched or moved, it's just been reflected and moved across. So our equation would be y equals negative x plus 4 all squared. With b, first of all, let's start with our origin. Now it hasn't been reflected, which is good. So there's going to be no negatives out the front. But we can see our origin here has gone across to 3 and then up by 2. So we know we're definitely going to have in here an x minus 3 all squared, and we're going to have a plus 2 at the end. Now we just need to work out if there's been a stretch. Now if you look here, the graphs don't look quite the same in terms of how wide they are. They look slightly different. So we just need to look at a couple of points. So if we look at the point 1, 1, if we were to do what we've done so far, we would move across by 3 and up by 2, which would be here, which hasn't happened. It is less than that. It's the y value stayed the same, but it has moved down. And it has moved down by half from where it should be. Now because it's moved by half on the y-axis, it means this whole function here has changed by a half. So we need to put the half out the front of the brackets. And that is translations.